All right, now we need to be careful when we're working with radical equations that we don't end up with an extraneous solution, because when we're squaring or taking the square root of something, that really impacts our positive and negative solutions, right? If you square something, it won't be negative because you eliminate that negative. And if you take the square root of it, right, that can have an impact on the positive or negative as well. So you just need to make sure that whenever you are solving radical equations this way, that you're checking your solution to make sure that whatever you get as your answer makes the statement true, is true for both sides of the equal sign, right? And then these examples that I'm going to show you also are kind of a step above what I just showed you in the last video, a couple videos, because it's going to involve some factoring, because we're going to end up with variables that are raised to different degrees, okay? So if I were going to go about solving this, we know that the first thing that we need to do is to get rid of this radical. So we're going to square both sides. Squaring it eliminates that radical there, inverse operations. So I'm left with whatever's on the inside. 4 minus 3x equals x squared. And now at this point is what I'm talking about. You're like, shoot, how am I going to go from here and solve x? Because these are not like terms. They're raised to a different degree. So what you're going to need to do is set up a polynomial and then factor it, because that's how we solve for x when we have x raised to 2 different degrees. Okay, so we want to get our polynomial. So we're going to move these all over to one side. So I'm going to add 3x to both sides. That leaves me with 4 is equal to x squared plus 3x, and then I'll move that 4 over. So I'll subtract 4 from both sides, and you end up with 0 is equal to x squared plus 3x minus 4, right? We have a polynomial here. Now you want to go about factoring this, and this is a simple one to factor. Just bring it back to what we learned like when you first started learning how to factor. What multiplies to be this number and adds to be this number. So multiplies to be a negative 4 and adds to be 3. What factors? Well, how about positive 4 and a negative 1, right? 4 minus 1 is 3, and 4 times negative 1 is negative 4. So that would leave us with x plus 4 times x minus 1 is equal to 0. And then you want to set each one of those factors equal to 0. So you have x plus 4 equals 0 and x minus 1 equals 0. And when you solve each of those, you get x equals negative 4 and x equals a positive 1. Right? So in this case, we have 2 solutions, which we haven't had before, but let's go back and check our answers to make sure that they are both true, right? Is x equals negative 4 a true solution? You want to substitute that back into your original equation. So I have the square root of 4 minus 3x, but x I'm saying is negative 4, is equal to x, which I said was negative 4. I'm only checking this solution right now. Does that make this statement true? So the square root of 4 plus 12, negative 3 times negative 4 is a positive 12, equals negative 4. 4 plus 12 is 16. So the square root of 16 equals negative 4. Unless it's indicating you're just looking at the positive root here. So the square root of 16 is going to be positive 4, does not equal negative 4. So this is an extraneous solution, meaning it's not really a solution. We got that as an answer because we solved it this way, but that's not truly a solution. So you just wouldn't include that in your answer. You would just totally ignore that. And when you boxed in your answer, you would box in whatever you find to be true. So let's see, does x equal 1? Is that a true solution? So I'm going to take this, And I'm going to substitute that back into my original equation. So that was the square root of 4 minus 3x equals x. And when I sub that in, the square root of 4 minus 3, x I said is 1. Does that equal 1? Well, the square root of 4 minus 3, 4 minus 3 is 1. Does the square root of 1 equal 1? Yes, it does. That's a true solution. So we would say that our answer is x equals 1. Okay, let's try one more example like this. If I'm solving for p here, the first thing that I need to do is get rid of my radical. So I'm going to square both sides. So I'll square this to do the inverse and cancel it out. And when I square this side, you want to make sure you're squaring that whole expression. Well, when I'm squaring this whole expression, that really is like saying I have p plus 1 times p plus 1. And then you can distribute that out and you know that you're going to end up with a polynomial. Hopefully you are really good at patterns, and so you know off the bat what that polynomial is going to be. If not, you can just distribute it out and simplify it from there. But the answer that you're going to get should be p squared plus 2p plus 1, right? I just squared it, and then I knew I was going to have to add 2 of those together, and then squared that bottom answer at the end. Is equal to whatever I had on my left side, which when I squared it, this canceled, was 7p plus 15. Okay, now I know that I'm trying to solve for p, which means I'm trying to get that p by itself. I know I'm going to have to end up factoring this, so I want it to be a polynomial equal to 0. So I'm going to go ahead and move this to the other side. So I'm going to subtract 7p and 15 from both sides. So minus 7p minus 15 on both sides to make it cancel out. I'm left with p squared minus 5p minus 14 equals 0, right? I just added straight down the line, left me with 0. Now you can go ahead and factor this side. So what two factors multiply to be negative 14 and add to be a negative 5? How about negative 7 and a positive 2? So I would have p minus 7 and p plus 2 are equal to 0. Then you want to set each factor equal to 0. So that's going to give me p minus 7 equals 0 and p plus 2 equals 0. So p is 7 and p is negative 2. And now you want to check for extraneous solutions. So I'm going to check this one first. Does this make my statement true? Does 7 plus 1 equal the square root of 7 times 7 plus 15? Whoops, that should be a 7. 7 plus 1 is 8 equals the square root of 7 times 7 is going to be 49 plus 15. So I'm left with 8 equals the square root of 64. Is the square root of 64 8? Yes, it is. So this is a true solution. Now let's check our negative 2. And I'm going to just take negative 2 and substitute that back into my original equation. Does negative 2 plus 1 equal the square root of 7 times negative 2 plus 15? Negative 2 plus 1 is negative 1. And the square root of 7 times negative 2 is negative 14 plus 15. Does negative 1 equal the square root of 1. Negative 14 plus 15 is a positive 1? No, because the square root of 1 is a positive 1. It's not negative 1. So this is not true. That's an extraneous solution. So you would say your final answer for this one is P equals 7.